Today, I'll be taking you on the topic verification of Ohm's law. On the verification of Ohm's law, our experiment for today, we get one question and we practicalize the experiment in order to verify the Ohm's law. So our question will be,
Talk to me.
where's the method? Here on the board is our question, and this diagram will serve as a guide in performing the experiment. Here we have a cell, next cell. So two cells makes this a battery, and from the positive terminal of the battery, with the help of a connecting wire, this line serves as connecting wire. It's connected to the positive terminal of the ammeter. This symbol shows ammeter. From the negative terminal of the ammeter connected down to one of the terminals of the unknown resistor, and from the other terminal of the unknown resistor to one terminal of the key. Here's our key. And from the other end of the key to the rheostat, and from this other terminal of the rheostat down to the negative terminal of our battery. And if you look closely, we have a voltmeter here, which is connected in parallel to the wire from the positive terminal of the battery. This wire. The positive terminal of our voltmeter is connected to the positive terminal of the wire coming from this. Here's our question. And this symbolizes battery, ammeter, voltmeter, unknown resistor, our key, and rheostat. From the positive terminal of our battery, with the help of a connecting wire, goes down to the positive terminal of the ammeter, and from the negative terminal of the ammeter to one terminal of the unknown resistor, and from the other end of the unknown resistor to the key, from the other terminal of the key to the rheostat, and from the other end of the rheostat goes to the negative terminal of the battery. Down here we have voltmeter. The positive terminal of the voltmeter is connected at this juncture, where the positive terminal of the voltmeter meets with the positive terminal of the battery. And this other end, the negative terminal of the voltmeter meets with this other wire from the negative terminal of our battery at this junction. So having explained our setup, the methods, set up the circuits as shown above in the diagram, and we will set the rheostat to a large value. Take the readings of the current and voltage. reduce the value of the rheostat and take new readings of current and voltage. We have to proceed in this way until about 5 pairs of values have been obtained. Then we tabulate our results. Here is the table for the tabulation, and the last question is to plot a graph of voltage against current. So let's go to the practical aspect. Here we have our battery. Here we have our battery. These are our connecting wires. More of the connecting wires. Yeah, this is our voltmeter. You can see here V. This one is our ammeter. Here's the unknown resistor. This is the rheostat we'll be using. Here, this is a key. And this way, the key is open. So that way, the key is closed, which will let current to flow. So using our diagram on the board, let us arrange it and check out the experiment. After successfully doing this, we have our voltmeter to connect in parallel. Now we have successfully set up the diagram here. So let's run the test. As you can see, it's reading. From our just concluded experiments, the cells were arranged in series. Now let's talk about arrangement of cells in a circuit. Cells can be arranged in two ways. One, series arrangement. Two, we also have parallel arrangement. So let me talk about series arrangement. In series arrangement, the cells are connected end to end. This means the positive terminal of one cell is connected to the negative terminal of the other cell directly. And a series arrangement will look like this. Here we have the diagram of series arrangements. This is cell 1, cell 2, and cell 3. Here is the diagram of series arrangements. We have cell 1, cell 2, and cell 3. In series arrangements, voltage across each of the cells are different, but the current across them are the same. And in series arrangements, also each cell assists each other, whereby if you have 3 cells and one is not working, you might not notice it because each of the cells are being assisted by one another. Here is EMF 1, EMF 2, and EMF 3. EMF means electromotive force. This here stands for internal resistance. This is the internal resistance of the first cell. And what is internal resistance? Internal resistance is the opposition to the flow of current offered by the chemicals between the poles of the cell. Having known what internal resistance is, let's go over. In series arrangements, total EMF of the cells is given by the sum of all the EMFs of each cell. And internal resistance, total internal resistance is given by addition of all the internal resistance of each cell. Next, we go to parallel arrangement of cells. Parallel arrangement of cells. This is an arrangement whereby all the negative terminals of each cells are joined at one point and all the positive terminals of those cells are joined at another point. Here is a diagrammatic setup of parallel arrangements. Let's take here to be P. This is the positive terminal. As you can see, all the positive terminals of each battery is connected to this common junction, and all the negative terminals connected to this other junction. Let's call it Q. Total EMF of cells in parallel is given by in parallel arrangement of cells, all the EMFs are the same. Also, in parallel arrangement, voltage across each of the cells are the same, while internal resistance across each of the cells are different. In parallel arrangement of cells, total EMF is equal to one of the EMF of the cells, which means that all the EMFs of the cell are identical and the voltage across each of these cells are different, but the currents across them are. Total EMF of parallel arrangement is equal to one of the individual cells EMF, and in parallel arrangement the voltage across each of the cells are the same, while the currents across the cells are different. We have a total internal resistance for parallel arrangement to be equal to having known this, to find our total arrangement, we take the LCM and make internal resistance total to be the subject of the formula. Having did this, we are done with today's class. My name is Nzova Barifidelis. Watch out on our next video where we will use resistance box to vary the current that flows across cells. Today we are using a rheostat. On our next video we will be using a resistance box. Thank you.